Amazon, DoorDash, Netflix, these are all full stack applications. And the interesting thing is that under the hood, they all share the same high-level architecture, which is exactly what we're going to talk about today. Thanks to AI, it's never been easier to build your own full stack applications, but that's also why it's never been more important to learn these fundamentals so that you don't make critical mistakes. It's super easy as a beginner to expose API keys or sensitive user data, so understanding how all of these layers fit together is really going to help you build secure production-grade applications and know what to look for in the code that AI generates for you. By the end of this video, you're going to be able to build your own full-stack apps confidently with the help of AI. So let's dive into the structure of a full-stack application. The analogy that I like to use is that of a drive-thru because it has all of the components which map so perfectly to what a full stack application does. First of all, you have the menu. This is like your front end or your user interface. This allows you to see what's possible in the application. And once you know what you want, you're going to make a request through the order window, which is essentially what an API is. This is the second layer of a full stack application. Once your order has been received, it's going to go back to the kitchen, which is like the back end. That is where a lot of the magic happens, but you do not have visibility or access to that part of the application. Now, in the kitchen, the staff are going to assemble your order, but they need to use ingredients from the pantry to put it all together. So the pantry is essentially like our database. It is used by the backend to put orders together, and it persists even when the restaurant closes for the night. So if we compare the two side by side, in the drive-thru, you see the menu, which is like your user interface, and you make a request through the order window, which is the API. Your order gets made in the kitchen, which is the backend, and ingredients from the pantry are used to put together your orders, and that is essentially the database. So these are all of the layers of a full stack application. And over the course of this video, we're actually going to create a digital version of the drive-thru so that you can see how all of these layers work together. Now let's dive into each of the components and take a closer look. The first one is our front end. And the front end is what your users can see and what they can interact with. Now the interesting thing is that regardless of what website you go to, you're always looking at a combination of three technologies: HTML, CSS, and JavaScript. And what happens when you go to a website is that your browser simply requests those files from a server, downloads it to your computer, and then displays it. So the front end is always running on the user's computer. And regardless of the framework that was used, it always boils down to those three files. So even if you're using a sophisticated framework like Django or React, it always compiles down into those simple files that get downloaded to your computer and then run in the browser. These three front-end technologies have distinct responsibilities. HTML is responsible for structuring the page and defining what is on it. CSS is responsible for styling it so that it appears nicely to the end user. And JavaScript is responsible for any sort of action, such as updating the UI when a button is clicked or calling an API to get some additional data. Any computer can be configured to allow users to download these files, but typically websites will use a CDN or content delivery network, which is a network of servers that host all of these files in different geographic locations so that people all over the world can quickly access your website. Now here's something important to understand. Your users have complete control over your front-end code. That's right. If I go to Amazon right now and I press F12, I can see all of the code that makes up the Amazon front end, which means that if I want to change this price to $1 instead of $79, all I have to do is change this number, and now it appears as if it costs only $1. You're going to see that this is exactly why we need a backend, which users cannot modify, to ensure that users cannot just change the price of an item and then purchase it at a lower price. Backends, as you will see, do not allow this level of control that a user has over the front end. So this means that you can never rely on your front-end code to enforce any sort of security. If you try to restrict users from taking a certain action by disabling a button, well, a user can simply go and re-enable that button in the front-end code and then click it anyway. This is the sort of thing that you're going to need your backend to enforce. But before we get into that, let's go ahead and use AI to build a very simple front end for our digital drive-thru. To build our drive-thru, I'm going to be using Cursor, which is an AI-powered code editor. It's very similar to VS Code, and you can in fact just use VS Code with GitHub Copilot if you want to do this for free, but I find that Cursor overall has a higher quality of output. So to start, I'm just going to open a project, and that's just going to be any folder on your computer that you want to have your code in. So right now I'm looking at a mostly empty folder. I just have a couple of things here for you because I'm going to be sharing this code on GitHub, so check the link in the description. But I'm going to go ahead and create a new UI folder, and this is where we're going to put all of our front-end code. Now in Cursor, if you press Ctrl L, it's going to open up the AI panel. You can also press it over here on the right. And I'm going to go over into Composer and select Agent Mode. Agent Mode is going to write code for you and immediately create and modify the files. So this makes it a lot easier than having to figure out what changes do I need to put into what part of my code, which is what you would have to do using something like ChatGPT. So to get started, I'm going to go ahead and write my initial prompt, and I'm going to be using voice to text. If you're on a Mac, just press the function key twice. If you're on a Windows, press Windows plus H, and it's going to start transcribing whatever you're saying into the input box. So I'm going to keep our drive-thru code pretty simple, and this is what I'm going to ask. I'm building a digital version of a drive-thru to act as a demo for a full stack application. I want to first start by creating the front end in the UI folder, and I want to use simple HTML, CSS, and JavaScript. Please create all three initial files for me. The UI should feature a menu board which the user can use to select the items that they want to purchase, and then a purchase button down below. So as you see here in my prompt, I give it some context about what I'm trying to do, and I specify the technologies that I want to use that are going to ensure that this thing stays on track. I'll submit that request. I think we already have a UI folder, but I'll just run this command that it's proposing anyway. Alright, so it looks like it was able to write all three files for us, and then it explains what they're doing here. So index contains a header, menu selection, order summary and purchase button. The styles define how this is supposed to appear, and then the JavaScript is going to handle some of the ordering functionality. Now you can open the index.html file in your browser. So let's go ahead and do that. Let's take a look at what index.html looks like. I'm just going to copy the path, and then we'll open up Chrome and go there. All right, take a look at this. We got a super basic UI. Let's see if we add items to the order, what's going to happen. Looks like we got a little cart here. Okay, very cool. But there are a couple of things that I would like to improve. First of all, I would like to have some kind of image. Over here, this number seems to be offset from all of the other ones. And then when I see my order, I want to have some kind of quantity field so that I don't see copies of the same item. I'll go ahead and request those changes to be made, and then we're going to actually walk through some of this code so I can explain how it all ties together. Please make the following changes. There should be an icon next to each menu item. We want to have a quantity field so that users can see how many of an item were purchased instead of duplicate copies. The price for the soda seems to be offset from all of the other ones, so can you fix it to make sure it's aligned? I'll go ahead and submit that request, and now what Cursor is going to do is it's going to modify these files to fix these specific issues. And thankfully, I'm not going to have to go and copy paste little snippets and find the right place in the code to insert them, so the Cursor agent is just going to do that automatically for me. All right, the changes have been made. Let's flip back over and refresh. And now it looks like we have some icons, not all of them though. The prices have been aligned, so that looks nice. And let's try to order the same thing twice. There we go. Now we see that there is a quantity, and I can add or remove more of the same item. I'll go ahead and accept all of these changes, and now we have these files which we can read through and try to understand what is happening. So if we look at the HTML file, HTML is responsible for defining what is on the page. So you will see all of these tags, and you can see that Cursor will actually connect these two because these tags are inside of this div tag. We're going to have a dedicated video about building front ends. It's actually next in the AI Coding 101 series, in which we'll go into the details of how all this works. But at a high level, you can see that there's a sort of structure to this HTML that defines how the page appears. So over here, we have the menu kind of at the top, right? We got this burgers header, and then under that, we have some menu items, which includes this classic burger, and we have the price, and then this cheeseburger, and that also has a price. So if we flip back over here, we can see that these elements correspond with this HTML that we have. Now, if you recall, you can always see the code for the front end in your browser. So when I go to inspect element, we can actually see the same HTML over here. And right now it looks super clean and matches exactly what we have because we have a very simple application. When you get started working with frameworks, you end up having the framework actually generate the HTML for you. So you don't know exactly what it's going to look like in the final version, but you can always go and see the HTML of any website that you're using. So here we can see how it perfectly aligns to the code that we have here. Now our CSS file over here defines how things are going to appear. So that is what is causing this text to go all the way to the right. That is what's causing this button to be blue and there to be some space in between these two little cards. So we'll get into more of that in the front end development video. But the last thing I want to show you is the JavaScript, which is responsible for all of the functionality on a site. So when I click this Add to Order button, JavaScript is running to make sure that this part of the website gets properly updated. And you'll see that when we implement our backend and we connect the API, the JavaScript in the front end is going to be responsible for calling the right API endpoint to get the correct data. Now, if I press complete purchase, we see basically a summary of our order, but we are not yet calling an API because we don't yet have a backend. Speaking of which, let's talk about what a backend actually is, and then we will implement that portion of the application. Now that we have a functional front end, let's talk about the backend, which is sort of like the kitchen in our drive-thru analogy. They receive the orders, they follow instructions to fulfill those orders, and then they respond back to the customer or the user. Backend services can be written in any number of different languages, so they don't have the same technological restrictions that you have on the front end. But why can't we just have all of our code in the front end? Why do we even need a backend? Well, there are a few critical reasons. Number one is enforcing security. Users cannot see what is happening in the backend. So if we have a secret sauce that we like to add to some of our menu items, you wouldn't want to expose that through the front end to the end user. You would want to just use that sauce to complete the order and then deliver the completed item to the end user. They don't have to know exactly what goes into it. So anytime you have some sensitive data that you want to protect, like the API keys to an AI service, for example, you definitely want to keep that only in your backend server. And connected to that is handling data access, because you don't want users to be able to request other users' data. So you need to have a way to be able to verify the user requests that are coming in, and then only give the data that that user is permitted to see back to them. Another reason you would need a backend is because of processing power. Since the front end is delivered to the user, it runs on their computer. So if you want to do something that is compute intensive, like generating AI images, that's not something that you would be able to include in your front end code because your users likely don't have really powerful graphics cards that can generate AI images. So instead, to build an application like that, you would have users submit requests with a particular prompt. You would process that on your servers, which have those graphics cards, and then you would respond with the images back to the users. Those are some of the main reasons you would use a backend server, but there are others, such as being able to schedule and run processes when the user isn't using the application, as well as coordinating actions across a number of different users. Now, I want to talk about the word server for a second, because I think this confuses a lot of beginners, since the word has different meanings in different contexts. Server can mean a literal computer that's probably at a data center that is available to run your application. It could also mean a virtual server, which is like a portion of a physical server dedicated to running your application, or it can mean the backend application that you have running on the server. So if somebody says, let's make requests to the server, they're probably talking about the application that's actually running, not the physical hardware. However, if they say something like, let's deploy the server, it could mean a number of different things. It could mean deploy the application or spin up the actual virtual machine that's going to run the application. So it can be a little bit confusing, but just know that it can be sort of used interchangeably and has these different meanings. Also, you might have heard of something called serverless, and that name is kind of confusing because no matter what, your applications are running on a server somewhere. Serverless just means that the cloud provider that you're using is going to handle the scale and maintenance of all the physical machines instead of you having to do it yourself. Serverless functions are just small pieces of code that get spun up very quickly on these servers and then get spun down when they're no longer needed. This can be a really good architectural approach for handling lumpy sort of workloads that can spike up and down, but there are also trade-offs that you're making when compared to more stable, long-running servers that you manage yourself. The important thing to keep in mind that the backend or the server is the part of your full stack application that your end users do not have direct access to. So let's go ahead and use AI to build a basic Node.js backend for our digital drive-thru. Going back to our drive-thru code, I'm going to go ahead and open a new composer or a new chat, and I'm going to ask the following. Please create a new server folder which contains a Node.js server that is going to put together orders based on a set of ingredients. For now, do not include an API or any sort of database connection because we will build those portions of the application later. I simply want to be able to assemble orders based on ingredients that we have. And for the moment, you can use objects that are stored in memory. I'll go ahead and submit that request and Cursor will get to work. One thing I mentioned here is that I want objects to be stored in memory. So this is essentially like a short-term memory that the server has, and it is accessing the memory of the computer that it is running on. When I restart the server, it's going to get completely wiped out, and you'll see this is why we actually need to use a database later in the process. Okay, looks like Cursor has created our server folder and has added several files to it. So we're starting with this server.js file, and looks like there is a super basic API here. We'll get into the details of what an API is a little later, but for now what we're more concerned with is this order service, which is going to actually assemble our orders for us. We also have a menu data file, and looks like in here this is essentially defining what our menu items look like, the prices and the names, and then our ingredients and how much we have in stock. Again, this is going to be reset every time the server restarts unless we have a database. One thing you'll see here is that each of these recipes has a list of required ingredients, which is exactly what we're going to need to track and make sure that we have enough inventory for assembling the order. Now looking back at the order service here, one thing I notice is that it's using a class here, and this is just a personal preference thing, but I try to stay away from classes. I like to just keep things really simple as functions because that helps me reason about the code more easily. So I'm just going to ask it to refactor this code so that it is using a more functional approach. Please refactor the code so that it is using a more functional paradigm. Okay, now that Cursor has made these changes, you can kind of see that we have very clearly defined functions that are responsible for specific things that accept certain inputs and generate certain outputs. So it's going to be a little bit easier to read through this now. And it looks like Cursor got a little carried away and went ahead and implemented most of the API for us. And we'll cover that in more detail later in the video. But for now, I'm going to go ahead and accept all of this code. And then we're going to talk about databases, which are an important component of the full backend. Now we have a basic Node.js backend in place, but it doesn't persist any of the inventory and it doesn't have a way of accepting orders. If I restart the server, it's simply going to reset the inventory. And what's more is that across different servers, the inventory is not even the same. So how do I make it consistent and persistent? Well, that's where the data layer comes into play. And this is essentially like the pantry in our drive-thru that contains all of the ingredients. Regardless of which server is used, they see the same inventory and they update it as they take ingredients in and out. Without a database, all of your data would simply disappear every time you restarted the server. The data layer is going to enable us to persist data that we care about across multiple user sessions and server restarts. There are different types of data storage for different use cases, but generally speaking, you'll have file-based storage for things like images and documents, and then you'll have a database for smaller records that you want to be able to quickly access and keep organized. When it comes to databases, there's generally two different variations. There's relational or SQL databases, and there are NoSQL databases. In relational databases, your data is going to be stored in well-structured tables that you define, and you'll be able to use SQL, which is a query language, to retrieve just the pieces of data that you need, or to be able to join multiple tables together. This can be a great option if you have very well-structured data. On the other hand, if you're dealing with a lot of unstructured data and all of your records have different fields and data structures, you're probably going to be better off going with something like a NoSQL database, such as MongoDB. These databases are designed to be used for situations where you have a more flexible data structure. There are many different types of databases with strengths and weaknesses depending on what you want to do, but generally speaking, you're probably best off starting with a general purpose database like Postgres or MongoDB, which will give you a lot of flexibility and community support. Regardless of which database you use, the thing to keep in mind is that only the backend talks to the database. You'll have some databases that have a server sort of built in, such as Supabase, which actually puts a server in front of the database and then has an API to let you communicate with that database. But as you're trying to reason about how applications work, just keep in mind that you only want to talk to the database from your backend server. So let's go ahead and get back to our digital drive-thru, and we're going to use Postgres to add a persistent inventory to our application. The easiest way to work with a database is going to be to install it directly on your computer, and I recommend using either Postgres or MongoDB. So just go to this website, link in the description, and you can download a copy of Postgres. That's what I'm going to be using for our digital drive-thru. Now, I also recommend that you get a program that is able to interact directly with the database called a client, and I recommend pgadmin if you're using Postgres. So I'm just going to connect to my local Postgres here, and we're going to be using this to query our database directly to make sure that we have the right ingredients. But for now, let's go ahead and actually connect it to our digital drive-thru to make sure that when we place orders, things are being updated. I'm going to go ahead and create another new composer, and in here we're going to say, I want to start tracking our inventory and orders in a Postgres database instead of in memory. Can you please add the integration to do that and hook it up to all of the relevant files? I'm going to specifically also tag the files just in case Cursor Agent overlooks it. So I'm going to tag the menu data and the order service files. This is going to ensure that the Cursor Agent has all of the relevant context. What we're doing here is we're asking Cursor to write the code that is going to connect to the database and then retrieve and update the various items in our various database tables. We're going to have tables that contain things like the ingredients, and we'll use this new code that's generated to actually update the quantity in our database. So it looks like Cursor was able to write all of the code, but now we have a few more steps to do, such as installing the Postgres dependency and configuring our environmental variables. So first of all, let's go ahead and run this. And it looks like it actually installed it outside of our server, so that's something to watch out for. Make sure that all of these commands run in the correct location. So I'm going to first cd server and then npm install pg. And for the environmental variables, I actually want to use .env, which is a specific dependency that you can use to help manage environmental variables. So I'm going to ask Cursor to update the code to use that. Please use .env and create a .env file for the environmental variables. So we'll run this additional dependency. Okay, I think it put the .env file in the wrong place. Let's go ahead and move that over into our server. All right, so it looks like .env was installed. One of the things it's asking me to do is run this SQL script, and I'm actually going to go ahead and copy this and run it directly in pgadmin, because this is the way that I like to interact with the database. So first, I'm actually going to create a new database here, and we'll call it Drive-Thru. Save. And now in here, we're going to run all of those SQL scripts. These are different commands that are telling the database to do something. So in this case, we are creating a number of different tables, and they are going to contain various different fields. I'll go ahead and run all of this. And now we can actually run a command that is select star from ingredients, for example, and we will see our table. So we actually see the data structure. Of course, there's nothing in it quite yet, but we'll add that in a moment. Let me go ahead and ask Cursor to write some scripts for me to populate the tables with some initial data. Please give me a SQL script that I can run to insert arbitrary initial data into these tables. I'll just fix that little typo and submit. All right, looks like we have this new SQL that we can run. I'm going to flip back over to PG admin, and we'll run all of that. Now, if we do select star from ingredients, we are going to see all of the ingredients that we have and how many we have in stock. So this is going to last beyond all of those server restarts. And when we place orders, our server is going to update this number so that we can keep track of how many we actually have left. I went ahead and accepted all of the changes over here. And now I want to talk about the API, and then we'll have this full backend kind of pieced together. I know that we moved through this pretty quickly, and when you're working on this yourself, I recommend that you really take your time and try to understand all of the different functions and what they're doing. But for the moment, I just wanted to show you the full end-to-end build, and then you'll be able to check out this code in the GitHub link in the description. But let's go ahead and talk about APIs, and then we'll have our backend complete, and we'll be able to tie everything together and start to see requests come in from the front end and go all the way down to the database. Now we have almost everything that we need. We have the front end, which allows users to see what they can order from the menu. We have the kitchen that can put together their orders, and we even have a persistent inventory in our pantry. But the thing that is missing right now is the ability to actually accept orders from our users. We need to build that API layer, which is essentially our order taking window in our drive-thru. An API is a part of the backend which exposes specific functionality publicly through endpoints that you create. The API defines the manner in which your front end can talk to the backend. So you might have certain endpoints that expect specific properties, and you will also respond with data in a particular format that the front end then has to interpret and display to the user. Most web APIs use HTTP to make requests, which is the same protocol that's used to actually load websites. So if I go to a website and I press F12, you'll actually be able to see all of the API calls that are made by the front end to the backend servers. So if I click on a note here, we see that several API calls get made, and I can actually take a look at the data that the server responded with. You can also look at other details of the API call, such as the request method and the status code that you got back. There are lots of little details when it comes to HTTP and making API calls, so I recommend that you spend some quality time with ChatGPT and you explore all of the various options. But regardless of the details, every API call is just a communication between the front end and the back end. One thing that is important to consider is that security is generally implemented at the API level. So if you have an application where a user signs in and they see their own orders, for example, you would have them sign in and the username and password get sent to your server where it is verified. And then the server sends a token back to the front end, which is then passed with every subsequent API call. Then the server can verify that this user is legit and give them only the data that they should have access to. This is a little bit simplified, and there are many different approaches to implementing security and auth in general. So again, I recommend that you just spend some time discussing it with AI, and there will also be a dedicated security video in the AI Coding 101 series. And one final reminder about security before we build out our API is that any security you implement in the front end can be bypassed by your users, which is why it's so critical to make sure that you keep your backend secure and you verify all of your user actions on the backend. All right, now let's go ahead and create our API so that our digital drive-thru can start accepting orders. So coming back to our digital drive-through, we already have actually an API in the server here. And like I was saying earlier, the API is really just a part of your server that defines the ways in which a front end can talk to it. So right now we have these various endpoints, and I'm just going to ask Cursor to double check that they all make sense given all of the changes that we've made to the code up to this point. And we'll also make sure that this API only accepts orders for items that we actually serve, and that the prices are set by the backend and not from the front end, because we wouldn't want people to name their own price in our drive-thru, right? Please verify that all of these endpoints are correctly configured and properly update data in our database and are ready for our UI to call. Make sure that we can only accept orders for items that we actually serve, and that prices are set by the backend and not sent from the front end. Go ahead and submit that. All right, so looks like Cursor has updated our API slightly to handle these cases, such as when we don't have a particular menu item, and also preventing orders that are completed from getting new items added to them. So that all seems to make sense. Let's go ahead and accept these changes. And now we should basically have the full backend in place. So let's go ahead and try to run it. To run it, you're going to need to install Node.js, and then you will run the command node server. This is going to start this server that we have. And the server is running on port 3000. Luckily, it looks like it did not actually run into any errors. And now if we go to our browser and we go to localhost 3000, we're going to see this error, which is fine. This just means that the endpoint that is at the root of this API is not defined. If we go to /health, we actually see this JSON response. This is data that is sent back to us from the server. So we can actually make API requests directly in the browser. But the limitation is you can only make GET requests in the browser. If you want to make more complicated API requests, I recommend using a tool such as Postman. And this is going to allow you to really configure your API calls and have various headers, different method types. It'll also allow you to save things. So it's a pretty useful tool. But for now, it looks like our API is up and running. Now we have all of the pieces ready to make our digital drive-thru functional. But before we wire everything together, I just wanted to share my thoughts on full stack frameworks such as Next.js, because these frameworks try to blur the lines between front-end and back-end, and I recommend against using them, especially for beginners. They do solve certain problems, but I think the trade-offs are generally not worth it for most use cases. Frameworks like Next.js commingle all of the backend and front-end code, which makes it really easy to accidentally expose user information or sensitive API keys through your front end. It's as simple as changing useServer to useClient, and you have suddenly made a part of your backend code public. If you have a lot of experience working with this stuff, yes, you can definitely avoid those types of issues, but I find that especially for beginners, it's really easy to make these sorts of mistakes. Additionally, it's going to be harder for you to figure out which API calls are being made, because a lot of the API calls that Next.js makes are going to be just partial updates to the HTML that is displayed to the user. It can become really hard to track down where issues are happening and what is happening in the front end and what is happening in the back end. That's not to say anything about caching and magical folder structures and deployment and build steps. Anyways, I'm going to get off my high horse about Next.js. As you might guess, I'm not a big fan. So if you're just starting out with this stuff, I strongly recommend that you build your applications in a way that keeps all of these layers cleanly separated, because you need to have a clear understanding of what is going to be public and available in your front end versus what you're keeping secret and private that is going to be in your back end, and have a clear mode of communication between the two. Once you understand the fundamentals, of course you can make an educated decision over which framework to use, but don't jump on Next.js just because it's the hot new thing. Now let's go ahead and finish our digital drive-thru and get everything working end to end. So for the final part of our drive-thru, we're going to hook up the UI to these APIs, and we should be able to see those requests go across in our DevTools network tab, and we'll be able to check our database to make sure that orders are properly submitted and that we update the ingredients list. Okay, so I'm going to go ahead and open a new composer, and I'm going to ask the following. we have created this demo digital drive-through as a way to display how full stack applications work. We have created a server folder which contains some code that fulfills orders and talks to a database and also has an API. And we also have a UI folder that contains our HTML, CSS, and JavaScript, which should actually call this API. But right now, I don't think the UI is actually calling any of the APIs. So can you please write the code to create the full integration end to end? The cool thing about Cursor agents is that they're going to go and look for all of the relevant files and find the context, so you don't even need to tag the files most of the time. When your code base gets really large, it does really help to curate the specific context that the AI sees, but when you're dealing with a smaller project like this, you can basically just have these open-ended prompts and the AI will figure out what to do. So you'll see here what it's doing is modifying this script.js file that is a part of our UI, and now it is going to start calling our API, which is located on localhost 3000. Localhost just means it's your own computer. So when you're dealing with a production application, this URL is going to look different, but logistically speaking, you're still dealing with an API that has specific endpoints. So if we just read through some of the code that it's already written here, look at this. We have a function to load the menu, and we're going to actually get the menu from our server. We are going to then display the menu, which is going to add certain HTML to our HTML file. So the UI is going to be updated with these new HTML tags. The way this is done in this code is relatively clunky, but it helps you understand the fundamentals of how this sort of stuff works. Frameworks like React solve this exact problem where you don't need to manage the exact specific HTML that is displayed to the user. They are going to dynamically update and fill your HTML with all of the relevant details, all of the special conditions that you define, and all of this kind of stuff. But at its base, what's happening is that the JavaScript is updating the HTML, which then shows something new on the page, and that's what the end user is going to be able to see. Okay, here's the moment of truth. Let's go ahead and refresh our digital drive-thru. And the first thing we get is an error, and that's perfectly okay because now we have a chance to troubleshoot this issue. So I'm going to go ahead and press F12, and we're going to look to see what kind of errors we run into when we load this page. When I refresh, over here, looks like there is a CORS error. And this is something you'll see often when you're getting started. So basically just ask the AI to fix this and it'll be fixed. This is intended to be an extra security layer in your API that is intended to make sure that only authorized clients can call your API. So what I'm going to do is actually go over to the console here and copy paste all of these logs back to Cursor. And I don't even really need to say anything. Cursor will just be able to understand what I'm talking about. It's going to go ahead and install an additional CORS package to allow our front end to call this API. All right, I'm going to go ahead and just restart this server. And then we'll flip back over to the UI and refresh. Okay, we got a different error this time. So it looks like our requests are making it to the server, but we have an issue with authenticating with Postgres. So let's fix that. I'm going to have to go to the .env file and just make sure that it is properly configured here. I know that my password is actually admin, so let me go ahead and do this again, refresh. Now we got another error, item.price to fix is not a function. And this is really just a typical way that you will develop software. You're going to build something, run into errors, fix those errors, then you'll see the next set of errors. So you really just need to get used to this and feel okay seeing these errors. It's just the next thing to overcome. The good news is that it seems like our API is being properly called. I'm going to go ahead and paste this issue back in. All right, looks like it's made some changes. Refresh, and there we go. Look at this. We have our menu. We got a couple of things that aren't exactly perfect, but we have a menu. Now, it looks very different from what we had before, right? Like we just had a burger and a cheeseburger and fries. And now, what are all of these items? Well, this is actually coming all the way from our database. So now that we have the full stack working, if I go to the network tab, when I refresh this, you see all of these requests, These are requests that our front end is making to our API. And then our API is actually responding with some specific data. So when we call the menu endpoint over here, this is the response that we get. All of this is pulled from the database. So let me go ahead and update the price for our spicy chicken sandwich. So if I do select star from menu items, I can see all of these items and their prices. Let's go ahead and update the spicy chicken sandwich to be $12.99. I'm gonna save the changes to the database. Now if I refresh, we can see that the spicy chicken sandwich is now $12.99. Let's go ahead and see if we can actually add some of these to our order. Looks like that's not quite working. I'll check console. Looks like there's an error here. Okay. So I'm going to go back to cursor and I'll say this appears to be working end to end, and now the API is responding with everything that we need. However, I am still getting some issues when I'm trying to add items to our order. I like to tell AI what went right and what went wrong because it really helps it focus on fixing the issues instead of trying to rewrite a bunch of code that already works. Okay, let's flip back over here. Now if I click add to order, well, we run into a different error, which is okay. We'll go ahead and copy paste this as well. Yeah, it's the same price formatting issue in this case. All right, it's made adjustments, refresh, and now we're able to add things to order. The total isn't quite adding up, and our quantity is gone, but we can fix that pretty quickly. Let's go ahead and see if we can complete the purchase. Thank you, your order will be ready soon. Amazing. And you know, the cool thing is we actually have an orders collection. So if we go over to the database and I do select star from orders, we should be able to see, here we go. I believe this is the order that we just made, this one for $38.97. And let's take a look in our ingredients table. Now we see that some of these numbers are quite uneven, and this is because we have actually placed an order and we've used up some of these ingredients. So let's take a look at this beef patty. It's currently, we have 132 of them, but if I order a couple of double burgers and we flip back over here, look at that. We have used 4 patties because each double burger has 2 beef patties. So this is pretty much working end to end. I'm just going to do a quick little cleanup and then the code will be ready. All right, we've made a few changes. Now when we add to order, we again see some kind of quantity tracker, which is great. Let me go ahead and try to order like a bunch of burgers. Oh, look at that. Before I even make the order, if I go ahead and try to add another item, it tells me that we don't have the ingredients that we need to actually fulfill that order, so it doesn't let me add it to the order. Now if I complete my purchase, there we go. That's a nice big order. Let's check our orders collection. And there it is, $750 worth of burgers. Feel free to check out this app and go ahead and play around with it. Add some features. Maybe you can add some icons or make sure that we can cancel an order and return the ingredients to the ingredients collection. Play around. It's a great starting point. Now we have a working digital drive-thru and you have a better understanding of the pieces that make up a full stack application. Next up, we're going to dive into the details of front-end development. From there, we're going to go down the full stack and have detailed tutorials for each piece of the puzzle. So make sure to subscribe and I'll see you in the next video. Thanks for watching. Take care.